So, so good afternoon to all of you. So now we'll start our afternoon session, second session for today. So first, I would like to welcome Dr. Tapas Kumar Jain sir to joining our workshop. And let me introduce a little bit about sir. Sir is currently working at IIT Nagpur in Department of Electronics and Computer Science Engineering. Sir has also worked with the IIT Kota. So sir has vast experience of teaching, almost more than 10 years of experience. Sir is especially working in the domain of clustering techniques like KNN. Today sir will explore this thing. And you have opportunity, many of the students was asking, sir is also working in the IoT based application and the sensor. So many of the students has the doubt, so they can interact after session with the sir. So what I will do now, I will hand over the session. On behalf of Department Computer Science Engineering, Manit Bhopal, I would like to welcome sir for this session. So now I will request to sir, please you take the session and I will hand over the session to sir. So, okay, sir. Thank you, sir, for joining.
Okay. Thank you very much, Vijay sir, for the generous introduction. And good afternoon, all my dear participants. And my name is, as Vijay has already introduced me, I'm working as assistant professor in IIT Nagpur. And prior to the IIT Nagpur, I'm in IIT Kota in 3 years. And I have the somewhere around the 19 years of experience, which include the industry and academia. And thank you for the MNIT Bhopal team to give me a opportunity to interact you all. And in this presentation, I have divided into 2 parts. One is the one, and in the second algorithm, and try to cover the k-means, and if the time permits, then also the hierarchical clustering. Right. So once again, good afternoon, and now I'll begin my session with the supervised learning, that is the KNN. And if you have any question in between, you can just the type into the chat box. So I'm happy to give the answer. And otherwise, at the end of the session, we'll discuss some question answer round as well. Right. So as you know, the difference between the supervised and the unsupervised learning, and if you say that if my data is labeled in the form, then it is supervised. If it is unlabeled, then we can apply the unsupervised learning algorithm. So this is the one of the type of k nearest neighbor of supervised learning. So there are the k nearest neighbor algorithm. There are the three. I'll just covering in the 3 parts. One is the definition about the KNN and the what is the factor of k, what is the value of k, how do we decide the value of k. Then I will move to the 1 or 2 examples, and then the strength and weakness of the KNN. So we have the different nomenclature of KNN, and the k nearest neighbors. It's also the memory based, example based, and when we every time when the new data point come into our data set, so the instant based learning, because we have to again recalculate the value. And also because when we add the new data point, we have to take the all computation again with respect to other data points. So simultaneously it is a the lazy learning algorithm as well, right? And as I told you, the basically the k, I don't know the lot of fluctuation in my screen, so I am able to concentrate on that particular app. I don't know what happened in this. Okay, so I don't know what happened. So I think I try to share my entire screen as well. Okay, so KN is basically the K nearest neighbors and one of the simplest supervised. So I hope my the screen is visible and also my voice is audible.
Yes, sir. Yes, sir.
Right. So in the one of these, okay, thank you. So it is the one of the simplest, supervised machine learning algorithm. As we, move to the next slides, I'll demonstrate to one or two example. Then you can, quickly realize it is how simple it is, and it is, basically the based on the neighbors values. And so first we have to identify the nearest neighbor, and then the do the some kind of voting mechanism to find out it is similar to which particular the data point. So basically used for
your
the
screen is
now
your screen is not visible, sir.
okay, so just a moment, I'll stop my sharing. I once again try to now it is
Yes, sir. Yes, sir. Now it is
visible.
Yes, yes, sir.
Thank you. So it is basically used for the pattern recognition, and K nearest neighbor store all the available cases. All the available cases means whenever the no new data point come, you have to again recalculate that particular case and add it into your database, and basis on the similarity measurement. So similarity measurement maybe the most of the time we are using the distance function, especially in the distance function is the Euclidean distance. This is also known as the norm L2 norms. You can also use the Manhattan distance and some other distances as well, L1, L2 norms as well in this to find out the nearest neighbors. And it is nowadays the top data mining algorithm used by the KNN. But as I told you, because it is the instant based learning, and whenever the new data point come into the picture, you have to recalculate entire things. So and that particular point, it is sometimes also known as the lazy learning algorithm. Now I'll just take the quick example of this particular data point. So now we have the in the figure number A, we have the further classify. We have the distinguished two data sets. One is in the red color, and another one is the the green color. And now we have to find out in this case we have to just find out this particular value. Green is related to either maybe are in the red color or maybe is in the blue color. Right. So we have to find out. In this case, suppose I just take randomly value, right? Let's say k is equals to 7, and this right. So first I have to find out the 7 nearest neighbor of that particular data point. So like this 1, you can take 2, 3, 4, 5, 6, 7. So this is the step number 1. First you have to find out the nearest neighbor. So I just quickly find out when if the k equals to 7, I find the 7 values. If k equals to 5, I can take the k equals to 5 nearest neighbor, and so on. So in this case, once you find out the step number 1, you find out the nearest neighbor, then you have to perform the voting. What do you mean by voting? So for this, in these 7 the nearest point, if you look at it carefully, the 5 is belongs to the red one. 5 is belongs to the red one, and whereas the 2 is belongs to the blue one. I'm not very good in rewriting of this because I'm not comfortable without pen. So anyway, so in this case, when we perform the voting, right, the 5 is belongs to red color and 2 is belongs to blue color. So majority is always go to the red color. so that this green data point is just behave as the red one. So this is just the process. So first you have decided the k is 7, then nearest neighbor. The second step is you have to find out the nearest neighbor. How many nearest neighbor? That depend upon k. So now k is 7, so I find the 7 nearest neighbors. What is the third step? Then perform the voting right. What are the data point is similar. So out of 7, if you look at there, the 5 data points are in the red color, whereas 2 data point is in the blue color. So the majority is goes to red. So that green node is just behave as the green node is behave as a red one. Similarly, if you look at the figure number B, if you find the object again in the green one, if the k, now you just find out what is the value of k. If you look at this, the green circle, and the how many data point is connected in between this green circle, if you look at it carefully, so obviously the k is equals to, in this case, is 3, and where the k is equals to 3, the first 3 neighborhood, but when we perform the voting rights, the 2 belongs to blue and 1 belongs to red. So in this case, the answer is what? Blue. Like that, you have to calculate the values. So now the question is, how to decide this particular value. So the important factor is, the k factor. So in the previous example, I took the value of k is equals to 7, and I took the value of k is equals to 3. So if we take the value k equals to 7 and 3, so most of the time in all my previous example, I take the value is odd. Why odd? Because I have to perform a voting. So if the number is even, if the k is even, then it would be, if sometime the result is tie, so the conflict result come into the picture. So number one, whenever you perform a k means k neighborhood, k nearest neighborhood clustering, you always take number one point. Keep in mind the k is value is odd. Point number 5. So avoid the confusion. Number one. Second is, because whenever you find out the voting process, so you want the nearest neighbor is the maximum, so you can perform the fair voting rights. So k is as max as possible, but we will go to the literature and all, the maximum value of k is the square root of data point. So for example, I have the 20 data points, right? So the square root of 20 is somewhere around 4 point something. So we'll in this case we'll take the value is 5. Why? We can't take the value 4 because it's an even number, as I told you. So I'll take the value of 5. So the maximum value of k is what? The maximum value of k is what? Is the square root of data point, right? So number one, keep in mind the value k is odd to avoid any type of confusion, conflict. Number two, the maximum value of square root of the data point, right? And now 3, can we take the k equals to 1? No. If we take the k is equals to 1, the problem is it is too sensitive to the nearest neighbor, and when the data point is overlap, we directly assign that particular value or whatever the nearest number, even in the single data point is nearest to the observed value, and remaining data point are entirely different, but then they assign the value is the same. So for to create some kind of noisy point, we avoid the value of k is equals to 1. We won't take the k equals to 2 because it is, as I told you, because we have to perform the voting rights, so we won't take the even numbers. So whenever we work on the k nearest neighbors, we always prefer the start value is k is equals to 3 to k is equals to 3 to square root of data points, right? So this is the just overview, but in case you also take k equals to 3, 5, 7, and you just find out the results, So maybe this result is maybe changed because it's not give you the accurate answer. So the choosing the right value is process called the parameter tuning, and it is started from k equals to 3 to the square root of data point value. Okay. So I hope this slide is clear to all. Now just quickly move to the when we apply this KNN when the data is labeled, because it is a part of the supervised learning. Data is noise free means when we you have the data is always when we talk about maybe in the rectangular format, so where that row is considered as a record and the column is considered as a features. So no row having the empty cells. So if there are the empty cells, when the pre-processing of data is required, we have to remove that particular cell. So the second one is the data is noise free. And if the data is small, because as I told you, it is very lazy. So data is small, so we prefer this technique because the less computational time is required. Otherwise, when we add the points and the large computational is required. But then too you can apply this k nearest neighbor to the large data set as well. So I'll quickly take the one example and we'll move to the okay, so I
Sir,
will start
sir,
the
excuse me,
example.
I was very little doubt here. Sir, here you are explaining
Yeah.
KNN, but I think same thing is also we are doing in fuzzy clustering. So it is different or same, because the same steps is also following in fuzzy clustering, and especially in entropy based fuzzy clustering.
Yeah, I'll differentiate. Just look at these my two example, then you automatically differentiate very well, right? So just
Oh, okay,
if
sir. Okay,
not, then
sir.
I'll definitely yeah. So in this case, if you look at it, as I told you, the data is what in the if you look at the data is in the rectangular format with the each row represent the record. So I have NA, John, George, Kevin, Tom records in my database, and where the features, if I talk about the age, income, and number of credit is my feature. So these are my features, and class is nothing but it's my outcome. So here we have the data frame. Number one, we have some records like the row. We have some column like features, and finally we have some you can say the output or target, or you can say outcome. This is known as my class. So my aim is to apply the k nearest neighbor and find out the tapan is belongs to which class, yes or no, right? So my data is there. If my age is 37 and my monthly income maybe is the 50k, and I have 2 credit cards, so which class I'm belongs to. So for that it's just very simple. How many features we have? 3 features, right? So we just calculate the distance with the help of equilibrium distance. So equilibrium distance formula is given on the bottom, that the root of xi minus xj square plus yi minus yj square plus zi minus zj square plus pi minus pj square, like so on. So you can apply this formula for the n dimensional as well, but this order is, yes, it is a norm 2, right? Because we have to take the square and the square root, so it's a norm, right? So in this case, so we have to calculate now the distance. So now number one, I have to calculate the distance from Tapan to NA. So this is nothing but 35 minus 37 square plus 35 minus 50 square plus 3 minus 2 credit card square, and just so we just calculate this value as the 15.16. Similarly, when we take the second value, Tapan to John, it come out to be 15. Tapan to George, Tapan to Kevin, and Tapan to Tom. So I have 5 distance values with respect to Tapan, and right. So when we apply the k means clustering, so first you have to decide the value of k. As I told you, k is not 1 and 2, so we'll start the minimum value because data size is very small. So we'll take the value is now k is equals to 3. right? So once we'll take the k is equals to 3, so that means we have to identify the 3 nearest neighbors. Now what are these 3 neighbors? This is on our distance. So if you look at the distance carefully, so the distance is Tapan to NA is minimum, right? Tapan to John is also minimum, and Tapan to Tom is also minimum. So these 3 are the minimum distance. Now once you decide the k, find out the neighbors, now the next step is what? You have to perform the voting. So if you look at the voting carefully, so NA answer is no, where the John answer is yes, and Tom answer is yes. So the voting percentage of yes is high as compared to no. So finally the Tapan belongs to which class? It is yes, right? Why? Because the 2 votes for yes, whereas the 1 vote for no. So Tapan belongs to the yes class, right? So I hope this example is maybe somewhat clear, right? So you have records, now you have the features. I apply the distance, equivalent distance in this particular example, norm to distance. I calculate the distance with respect to my data point which I have to calculate for Tapan's class. So I just calculate the distance from each other data points like NA, John, George, Kevin, and Tom. So these are the values. If you look at these values as well, right? So we find the nearest value. So what are the minimum distance? Are the nearest distance? So here the NA, John, and Tom are the nearest one. Then we perform the voting, right, and we'll clearly look at it because the number is odd. So maximum vote is goes to the yes class. So Tapan belongs to the yes class. So
Excuse me, sir. The K is
yes.
3 just because of the 3 characteristics.
K is what?
You are taking K is 3. K is equals to 3. You are taking it K is equals to
Right.
3. So it is just because of 3
Right.
characteristics: age, income, and credit card.
No. So the
Okay,
k
then
is
what?
won't be related. K is won't be related to the number of features, right? K is just depend upon your data size. As I told you, the minimum value start from k is 3. 1 and 2 I'll give you the answer as well, and the maximum value was the square root of the data size. So here my 5 data point is there, or maybe 6 data point is there. If I calculate the square root, so it's somewhere around 2 point something. So 2 even number is not be possible. So that's why I took the k equals to 3, right? So I hope this clear my answer. It is not at all related to the
Yes,
number
sir.
of features. Okay.
Okay, right, sir. Right, sir. Right, sir.
Okay, so I just erase this. So I hope this example 1 is clear now. I just quickly move to the example number 2. So another interesting example in this case, we have to the how many features now in this case? There are the 2 features, right? How many? It's 2 features. One is the age, another one is the loan amount. Wow, what is the disbursed loan amount? For that, this is your outcome. This is your outcome or output or target, right? This is your outcome target. So I have to calculate. Now I have the new data point come into the picture, and I have to predict this output. The new data point is nothing but this is the age is 48, and is the disbursed loan amount is $1,42,000. So I have to predict in which class this come. So for that particular case, again, if you talk about, again, we have to do the same thing. We have to calculate the the distance from 48 minus 25 plus 142 minus 40,000 square. And when we calculate the distance, if you look at it on the bottom of my slide, this is 102,000.0025. There's somewhere around 102,000. This is my distance. Okay, so you get, I think this. So similarly, you have to repeat for each of data point. You have to calculate the 48 to 35, then 48 to 45, then 20, and so on. And then basis on you have to calculate these all distances, right? Number 1. How many data point in this case? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, whatever. So if 11 square root then come out to be 3 point something, that means we can't take value 4 because 4 is even number. So in this case also we'll take the value k is equals to 3. We have k is equals to 3. We also calculate the distance. So how many nearest neighbor you have to find out? 3. So what are these 3 neighbors? If you look at this particular table, this is my one value is minimum, this is my second value, and this is my third, right? Clear? These three, 1, 2, and 3. Now we'll perform the same thing, the voting rights. So this belongs to no, this belongs to yes, this belongs to yes. So the 48 age and the disbursement amount is 1,40,000. The customer is default yes, because the yes having the highest voting, right? So this answer is yes. But the same time, if you look at the very carefully the distance matrix, the entire distance matrix is depend upon only for the loan amount, only for the known amount, not the the first feature, that is age. So there is this the some conflict or some confusion to find out the answer, because the entire term is just depend upon the one parameter, that is loan. So for to avoid these conditions, when we the parameter or our output or outcome will depend upon only one feature, instead of we have the two features. So how do we resolve these kind of problem? So to resolve this problem, we can do the normalization, the part. What do you mean by normalization? We converted the entire structure, we converted this entire structure into the normalized means 0 to 1 value. So if you look at the carefully, what is the the in age, what is the minimum value? You look at the table of age, this is the minimum value. What is the maximum value? This is the maximum value. So I want to calculate this normalized value 25. So I can use this formula. On the bottom right side, you have the one formula is there, right? This is nothing but your, what is the modified value? V is what? V is somewhere around 25, minus what is the minimum value of this particular column? 20. What is the range? Range means maximum minus minimum. Maximum minus minimum is what? 60 minus 20. If you calculate this value, what is that value is? It's nothing but is the 5 divided by 40, and it will come out to be 1/8, or you can say the 0.125. So because the entire table is dependent upon only one parameter, but we have in this particular problem we have two parameters. So how to involve this second parameter, that is age, into the problem? First we have to convert the entire features into normalized value. So the normalized values, how to calculate the normalized value? There are many ways to calculate, but in this case I am using this formula. This is the value minus minimum value divided by maximum value minus minimum value, and I clearly demonstrate the one of the value. If you look at it, so the value is 0.125. So you have to again entire this set you have to convert it into the normalized value. Same thing you have to repeat for the loan amount. What is the minimum value? This is your minimum value. What is your maximum value? This is your maximum value. So suppose 40,000 we have to convert. So 40 divided by 20. 40 minus 20, sorry. So this is come out to 20, and what is the range? 220 minus 20 is 200. 20 divided by 200, 1/10. So this value come into the 0.1, whereas this value is 0.125. Right. So we have to change this entire the record into the normalized value. So or why we do the normalization? Because in my first case it is depend only on the first case, right? So I just go to the
Excuse me, sir.
normalized part.
What is our objective here, sir? Excuse me. Hello. What is our objective, sir,
what
here?
Yes. So my question is, we have to find out whether this particular customer is default or not, right? When the age is
Okay, sir.
48 and the loan amount is 1,42,000, right? So we apply the
Yes, sir.
K nearest neighbor clustering and we find out the customer is default. But at the same time, we observe that
Okay.
the feature is only depend upon the disbursal amount, not the age criteria. So that will
Okay.
lead the wrong result. So to avoid the wrong result, and our the result will depend upon both the features, age as well as loan amount. So that's why we converted our entire data set into the normalized value. So for that normalized value, we are using this particular formula. All right. Okay. So we
Yeah.
converted into the normalization. Right. I hope this clear my answer.
Yeah. Yes, sir.
Okay, so now this is the modified, updated table. As we calculate the value is 0.125 and 0.1. So here you can write the 0.10 or 0.11. That will be not some kind of defect, and because it is the high value. So instead of you here is 0, you can write the 0.01 as well. So no change of your too much of calculations. So number one, in if previous slide, it depend upon only one parameters. Now I have converted these two features, age and loan, into the normalized value. This is my normalized value. Then again repeat the same step. Now this particular database, what is the value of K? K is again the same. K is again same. What is the K? Because 11 or 12 value is something around 3 point something. So we'll take the value K is equals to again 3. Now again calculate the distance, 0.7 minus 0.125 per square plus 0.61 minus 0.1 per square, and keep on calculate all these distances. This is on this formula. This is on the formula of equivalent distance. You can just calculate the distances. Once you calculate the distance, you have to find out the nearest neighbor. So what are these nearest neighbor is what? This is the minimum distance 1, this is the minimum distance 2, this is the minimum distance 3. Once you find out the minimum distance, then the next step is what? You have to perform a voting right? You have to perform your voting rights. So how do we do? Just take the result outcome of these three minimum distances. So here the voting goes to no is 2, whereas yes is 1. So the final answer is the no, because it is the ratio of 2/3. So 66% vote for no, so answer is no. So now you can clearly differentiate when we incorporate these two features. In my previous case, you can look at it. The previous case answer is yes, whereas now the answer is the no. So you have to observe the data very carefully, and basis on you can take the conclusion whether my result is depend upon one feature or two features. Right? So that's why we do the normalization and the recalculate, and then we'll have some different answer in this case. Right? So this is I hope this example is also clear to all. If you have any question, you can
Sir, it is
ask.
clear. But doubt is which solution is right, first or second?
So sir, you can clearly predict. Then if you look at the solution one is the problem is it is depend upon only the loan parameter. So this is not you just line up this loan amount in the ascending order and directly you can predict. So this solution is somewhere wrong, because it is depend upon only one features. But when we do the normalization part, it depend upon both the features, age as well as the loan. So probably the answer 2 is correct, right?
Okay, sir.
Otherwise,
And sir,
the simple thresholding, for one feature you can simple do the thresholding whether it is value is near to the threshold or not, right?
okay, and sir, one more doubt. Here we are having the
Yes.
number, but if we are linguistic, then we cannot calculate the Euclidean distance of linguistic terms. So then, how can the KNN work?
Just can you repeat this question, because your voice is break.
Sir,
So
here we
can
are
you
having
repeat one time?
numbers. Yeah, sir. Here
Number.
having numbers, but that is loan in loan age. But if we are having a range or in our data or linguistic terms, so can we use the KNN method with linguistic?
Okay. So as far as the question is concerned, sir is wanted to ask if instead of number, if there is some Boolean term or yes or no or some linguistic or some text message, can we apply the KNN or not? Right? That is the question.
Yeah, sir. Same.
Okay. So for that particular case, you have to convert some the distinguished labels, either 1 0 0 1 2, and then you can apply some other techniques, like for then you cannot apply the distance matrix. Suppose for example the default is one of the feature, right? So n is represented by 0 and this is represented by 1, like that. Suppose this. No? Okay. So for that you do no need to apply the you can say the Euclidean distance. Rather than you can prefer some other similarity technique, maybe a Jacquard, or maybe the 2 similarity point, 3 similarity point, triangulation method. So a lot of literature is available for this kind of similarity indexes. So you can apply that distance, that cost function as well, instead of the Euclidean distance. Even in the somewhere you can use the correlation factors as well to find out the KNN. So but you have to first convert it into some labels, and then you can apply the respective method in this KNN. Okay.
Okay, sir. Thank you. It is clear. Thank you.
Yeah. Thank you. So just move
Sir,
to the yes, madam.
one question, sir.
Yes,
Can
please,
we
ma'am.
taken as distance matrix generation time is one of the performance metrics of KNN? Distance matrix generation time. We are
Distance
applying for multi-class
matrix.
classification using KNN.
Okay. Mm-hmm.
In that we are taking the distance matrix. That means different distances, Jacquard distance, Euclidean distance we are applying. So can we take a distance
Yes, yes.
matrix generation time as a performance metric of KNN classification? Distance matrix time. Distance matrix
Okay. So
generation time from the feature data set.
no, I got your point, but I won't apply in the scenario. So probably we can use, because here the data is the supervised form, is labeled format. So yeah, definitely we can apply for that particular approach as well.
So is it a performance metrics? Can we take an as performance metrics?
No, not the performance metrics, because here our task is not the performance, because we have to give the result in the whether the customer is default or not, right? So
Okay.
as such, there is no the performance degradation in this case, right? So
Okay, sir.
if we talk about the performance, then you have to move to the unsupervised learning, where we cannot have the labeled data, right?
Okay, sir.
Thank you. So let's quickly move to, I think the time is, yeah. So by 3 minutes, I will try to bind up this KNN and I'll start some next session. Okay, so just quick review of the strength of the KNN, because it is very simple and intuitive. We can apply it in the data for any distribution, and good classification if the number of sample is large enough, right? And because it takes more time, because whenever the new data is come, you have to calculate for each of the data set points. So there is some trade-off between, because one time you said that the data is large enough for the classification, and the same time you have the more time consuming. So there is a trade-off between the time complexity and your data size. And choosing K is just obviously tricky because I said there are no specific rules to select whether K is equals to 5 or 7, but the limit is there. Of course, limit is there, but there's no. So for trial and error, you can just take the accuracy of that particular examples result. Right, and the same time we had look the example of the normalized as well. So once you complete result come into the picture, and then if you compare the distance matrix, it is closely related to the one of the features, then you have to go for again recalculation for the normalized value as well. So that is the the weakness of this KNN. Okay, so this is just quick. Any question related to till point? Otherwise, I'll start my next presentation on the unsupervised learning.
Sir, in the same KNN, when we are taking the single test input prediction, how we can calculate the accuracy, sir, using KNN?
So, madam, as I told you, we cannot predict this accuracy in the first book, right? Why? Because
Okay.
when we here in this case we are calculating our accuracy for prediction the new values. So do one thing. If you want to predict your accuracy, you can either just take the first 10 values in this case, and
Okay.
the 11th number answer, this customer is default, and then basis on these 10 values you can predict and then you can calculate whether my answer is closely related to exactly the yes or no, right?
Okay.
That way you can predict the values.
Okay, sir.
Any more question? So now this presentation is over, and I just quickly share my next slide.
Sir?
Yes, madam. Yes, madam.
Can we calculate the overall classification accuracy without splitting the data into training and testing?
No, madam.
Compulsory we need to. Hello?
It is not possible to calculate the entire accuracy of that, because madam, as I told you, because these are the the algorithm of machine learning algorithms. These are the soft computing techniques. They are not the hard computing techniques. So whenever you come to the soft technique, you cannot get the result at 100% accuracy, right? So
Okay,
even though
compulsory we
if
need to.
you calculate the value, even though if you calculate the value of sine 90° in this particular algorithms, it won't give you the
Okay.
one. It is always give you the 0.99999.
0.99 something. Yes.
So
Yes, sir.
because of the yes, so you cannot get the in any case, in my point of view, you will get the 100% accuracy, right?
So can we
Okay,
use
sir.
more
Okay,
than
sir. Thank you.
2 classifications? So can we use more than 2 classifications in this for KNN?
Because sir, in this particular case, if we talk about the classification point of view, because we know the outcome, right? We know the outcome, right, sir? So outcome is my
Yes.
case in yes or no, right? If
Yes.
the data output is ordinal type, maybe the excellent, very good, or good, yes, you can do it like that way also. So it depends upon
Yes.
the output. Yeah.
Yes. Yes, sir. Yes.
Sir, in one slide, you have written that if K is too small, then it is sensitive to noise points. So how actually, I'm not convincing.
Right, madam. So madam, suppose I take value K is equals to 1, right?
Sir.
And I calculate the distance. Obviously, the whatever the nearest node is, I have to take that result directly.
Yes, yes.
Okay. So that is the big problem. So that's why I'm taking it. Whatever the data nearest to you, you have to directly inherit that result. So that is the problem. So whenever we perform voting, at least the 3 votes is to be there. That's why.
Oh yeah, I got it, sir. Thank you.
Okay, thank you. So I hope my second slide is visible to all, right?
Yes, it is visible.
Hello, sir.
Thank you.
Hello, sir. Hello, sir. Yes, sir. Dr.
Yes.
Tapan Kumar, sir. Jain, sir.
Yes,
Yes,
sir.
sir. Yes, sir. Ask.
Nice to see you, sir. Sir, I have regarding doubts regarding IoT, sir. Hello, sir.
Regarding the IoT, so this is
IoT.
sir. Can we discuss after this session?
Oh, sure.
Just
Okay,
after
thank you,
this.
sir.
Yeah,
Okay, sir. Okay.
because the AI is, so most of the people is not comfortable. So
Oh, sure.
we'll take your question definitely, sir.
Okay,
Thank
sir.
you.
Sure. Okay, sir.
Yeah. So I hope this slide is visible, and now we'll quickly move to the one of the unsupervised learning. That is the the famous and most of the time people are using. That is the key means learning, right? So we'll just quickly go through. I hope you will know what is unsupervised learning, but I just quickly explain with the help of this diagram. If you look at it, in the first one, I have the input raw data, but I don't know the any kind of features or the values. Okay, so I have the input raw data, and the finally, if you look at the output is divided into 3 clusters or 3 category.
Sir, slide is not
So in this
changing.
case, when we talk
Sir.
just a moment, sir.
Slide is not changed, sir.
It's working.
Okay,
It's working.
Okay.
Just a moment, because it is fluctuating. When I move to the full screen, it will automatically go to the down screen. Just a moment. Can you tell me which slide is visual?
First slide.
The
You are
figure
in
one?
the PPT. Yeah, first slide. Home page. Yeah, now it's come the first page.
The figure one?
Yes, sir.
Yes, sir.
Okay, so because it is too much fluctuating, I I can't concentrate on this.
Okay.
But in my part, it is I have to look at it.
Sir, instead of running in the full mode, you can use in the basic mode. That is the PowerPoint construction planes.
Okay, fine. So now I hope my slide is visible to all. The figure one.
Yes, now it is visible.
Right, thank you. So in this case, if you look at the unsupervised learning, as I told you, we have the input raw data, and if you look at the last point output, we have data is segregated in 3 clusters, right? And just a minute, I'll be. Okay, sorry. So now in this case, if you look at the data is automatically divided. So the number one step is when we talk about the unsupervised learning, basically it deals with the the unlabeled data, right? So if you look at the previous example of KNN, there the the outcomes or target is there, but in this case there is no outcome and target there. So now second step is we have to interpret our own data, discover our own data, right? So So there is no as such any training data. You have to create your own data set in this case with the help of just apply the algorithm, machine learning algorithms like neural network and all. And once you apply the neural network, then here after the algorithm, you have the some contain some information of each of the data point, and basis on the information of the data point of after this algorithm, you process it and you segregate into the different clusters, right? So this is just an overview of the unsupervised learning, or you can say once you apply the one kind of the algorithm, then the some part of your data is become supervised, right, in between. So basically unsupervised learning is used for the clustering. Clustering is maybe you can split your database or you can group your database maybe or data point. That is one important. Or suppose one of the data point is very different from the all existing information. When you discover your information, one of the data point is entirely different. So you can anomaly you can detect, or you can detect the outlier, or any kind of the false transactions on your database you can clearly identify, because we have to create our own information, discover information. Association mining is there because we work on the subset part of also. We identify these sets of item into the database, and you can either you can split it, or you can differentiate directly with the help of these algorithms, right? So basically if you look at the here the figure is there where the automatically you can look at there are the 5 clusters there: green, orange, red, violet, and the blue one. So these are the clusters, and these again work on these clusters formation based on your Manhattan or Euclidean or the correlation, or you can say the Sorensen and Jacquard. So it's up to you this kind of the similarity measure you are using to formation of clusters. So cluster is most commonly the data analysis techniques, and people are working on the last 70-80 years on this particular problem set. So there are lot of k-means clustering variant is also available. So I am using the very simple application of k-means in this case. So here if you look at again the example, we have the all data points. We don't
I
know
think
the
again we
how
stuck
to
on the slide number 2. We are stuck on the unsupervised learning heading slide, first figure that you shown.
Okay, sorry. Now in the figure where the original and cluster data and cluster data. Okay.
The slide is cluster continued slide.
Okay, fine. So as I told you, when we formation of clusters, maybe the simplest data exploration or data analysis techniques, and it is a very old techniques people are using and still the people are using the different type of clustering, and it is widely used for converting the unclustered unstructured data into the structured data as well. So if you look at the figure 1, the all the data points is in the blue color, right? All the data point is in the blue color, and when we apply the algorithm of the k-means or any unsupervised algorithm, you can just look at the cluster is divided into 3 categories: the green, blue, and red one. So, okay, so there are different variant of the k-means clustering, different clustering algorithms. So but when we focus on the only k-means clustering, we have apart from this the mean shift clustering, kernel k-means clustering, k-medoid clustering. So the n number of clustering is available, and it is the very famous and the simplest clustering techniques, and people are still evolving and do the some kind of the modeling and prepare or demonstrate the different variant of the k-means clustering. So it is a very powerful clustering techniques. And if you look at my next slide, the Professor Jan is in the figure. He is Professor A.K. Jain is the famous highly cited Indian, and he's in professor of University of Michigan. And I have interacted in the last year in one of the conference on image processing. And sir is write a fantastic book on the data clustering techniques, and also the paper presented in pattern recognition letter in 2010. So now you can imagine how powerful is k-means clustering, because the title itself, the 50 years beyond k-means, and now the year is 2020. So now almost 60 years people are using the k-means clustering, right? So this is the famous you can say the researcher Professor Jain, and also he is the member of our world biggest bio informative projects, Aadhaar. So he's a key role behind the Aadhaar implementation. And so in this case, we'll just quickly go to the first example, and then we'll discuss a little bit about the theoretical aspects of that, because I have to try to cover the two unsupervised learning in this session. So number one is, it is the iterative algorithm. What do you mean by iterative algorithm? Means every time once you calculate the round one, if you are not satisfied, or they have some the values, you don't get that particular result, you have to iterate the same process again and again. But make sure the one data point belongs to only the one group or one cluster. Okay, so I'll explain quickly with the help of examples as well. So in this case, if you make the cluster, you can start from the intercluster data points, which is very similar to the points, and those points are very different. You can put into some other clusters, right? So how do you do that? You can basis on the same distance function. So the distance function may be a equilibrium, maybe a Manhattan, right? And when we work on this, then automatically the more the similar data points are, they fall into the same clusters.
Again, I
Yes,
think
sir.
slide is not changing. Slide is not changing, sir. Again, it is
I'm
showing
really
only
sorry.
a photograph.
Okay, I'm really sorry for that. So
I think the
the
slide is in
k-means,
the .ppt format, and the site is support PPTX efficiently or effectively, I think.
no, because it's running on my laptop, and I'm using the same desktop laptop. So okay, I'll do that. I'll just minimize the things, and probably I'll check it out what problem. So just a moment, I'll just. So I think that would be perfectly fine for you.
Yes, sir. Yes.
Okay, so I'll remove my full screen presentation mode. So in this case, if we talk about the k-means, as I told you, it is a iterative process. So with the example, it is more clear, but the make sure one data point belongs to one group. Number one, you can use any sort of distance function, okay, Euclidean, Manhattan, or any similarity matrices or correlation function, whatever, and this to calculate the relation. And simultaneously, if I take if the more the homogeneous points, more the similar points, will automatically fall into the same clusters. So in this case, we'll make the intercluster data point as similar as possible, and whatever the the data point, or you can say the cluster member are different, we will put into the some other bucket or different cluster, right? So in this case, our aim is to to minimize this the objective function. So how do you minimize this objective function? So we have to check, keep on just calculate the distance and just modify the centroid of the our function. And once you've modified the centroid function and each data point, because it is an iterative process, you have to calculate the distance. Once the function move to reaches to the minimum distance, then you have to stop that process, right? So suppose in this stage, if we take example, suppose this is the some data points, and if you take the cluster 1 and cluster 2 here, so point is that you have to calculate the distance. Now whatever the minimum distance you can assign, so I think this every data point is belongs to this particular node.
So again,
Now
slide
if you
is
look
not
at
changing.
this
The slide is not changing.
whatever I written, it's on the screen or not?
It is there now. It's coming. Yeah.
Yeah.
Okay.
Sir, but
Sorry,
please
sorry.
repeat the written thing, please.
Okay, so just I repeat the entire thing. It's just okay. So I am able to undo this part because of the, I think, maybe poor network connectivity. Okay, so I'll explain the entire thing with the help of this example, right? So we have the I don't have the control to delete this.
I will provide the control.
Okay. No, not yet. Okay, thank you. So in this case, if we talk about the key means clustering, so suppose this green one is our entire the data set, right? And we assume that the two clusters are the centroid are blue one and the red one, right? So one step is, now I have to calculate the distance. Now I have to calculate this distance from now I have to calculate the distance from each of the data point. If I calculate the distance from each of the data point, now you can look at it in figure B. If the distance is less from blue, that belongs to the green one in the blue cluster. If the distance is minimum from red, that it belongs to the red one. So if you look at the pink line in between, if you look at the pink line in between, in this case, if you look at the pink line in between, the clearly you can look at the two clusters. Some of the data point belongs to the blue one and someone belongs to the red one, right? Once you look at it, now what is the iterative process in this case? Now here, suppose in the bottom part, each of the data point is calculated a distance from that blue cross, and somewhere the distance is maybe a 1 or maybe 1.2 or 1.3. So now in this, the second iteration, I moved my cluster head and I assume the one of the data point is my cluster head, or that is the centroid of new value, new cluster. So I took in figure C, see the blue one. Now the move to this centroid is this particular. When we calculate, the average centroid of this value, the centroid fall into this area, and similarly the red one is fall into this area. Okay, and now again I reiterated the distance from the distance from this, and if you look at the number. I'm sorry, because it is too much fluctuation, so I cannot concentrate on the one particular slide. Maybe some poor network connectivity. So if I look at when I change my centroid value, then recalculate the distance. Now you have the pink line in the figure D. Is my figure D is visible to all? I hope.
Yes.
Okay, so you can get the the bifurcation of now the data points. Initially we start the data point somewhere here, and here the blue one, and in the previous figure is the red one. Now you can just keep on, our record is changing. So once you calculate the bifurcate this pink line, again recalculate the centroid. So centroid maybe come into this point, at that point, as you see in the figure E, and just keep on iterative once this distance is the minimum. So finally I'll get the the two distinct data set clusters in this case. So that's why it is the very iterative process, and each time you have to again modify the centroid value and then calculate. So I'll quickly take some other example, maybe probably that is clear the question. So I hope my example 2 is visible to all.
Yes, sir.
Yeah,
Yes,
fine.
sir.
Thank you. Okay, so if you now we want to apply the k-means clustering of this. So now in this slide I also mentioned how many total data point as well. So we have total 12 data points. So when we start this, suppose I have total 12 data points, so don't bother about these 12 data points, because it's iterative process. So initially I just bother about the initial 3 points, and is initially 3 point. I assume that I have the two clusters. I want to divide all my 12 data points in two clusters, right? So I assume that the data point 1 is my cluster 1, belongs to cluster 1, and data point 2 is belongs to cluster 2. I assume that one is belongs to cluster 1, another one is belongs to cluster 2, right? And now the new data point come into picture, that is point number 3. Okay, so from here we have the total 12 data points, and we have to divide this entire data point into two sets, two clusters. So we initially assume that the data point 1 is belongs to cluster 1, and data point 2 is belongs to my cluster 2, right? I hope there is no confusion in this, right? So now I have to check whether my data point 3 belongs to cluster 1 or 2, right? So the centroid, if I'm talking about here, the two different terminology, weight and height. But if you talk about the centroid of K1, so 72,185 is my first centroid. If you look at the K1, and similarly the centroid 2 is K2 is nothing but it is a 56,170, right? So we have clearly differentiate my centroid. Okay, the K1 having 72,185 and K2 centroid is 56,170. Right now, I move to I want to calculate the 3 is belongs to which cluster. So for that, first we calculate the equivalent distance from 1 to 3. So the equivalent distance from 1 to 3 is 72 minus 60 square, and the 185 minus 160 square, that come out to be this. Similarly, we have to calculate the equivalent distance from 2 to 3. So 56 minus 160 and 170 minus 168, that come out to be 4.5. Okay, so my the second slide is also visible to all. So now just keep concentrate on the center table one. So initially we have 3 data points. This is cluster 1, second one is cluster 2. We have calculated the distance 20.8 and 4.5. Which is the minimum? Minimum is 4.5. So the data point 2 and 3 is combined. That means the point number 3 is, the minimum distance is from data point or cluster 2. So this point number 3 or data point 3 belongs to the cluster 2. So we have just combined these two. So we have combined in this table 3, we have combined 2 and 3. So what is the next step? What is the modified centroid of cluster 2? So what is the modified centroid? It's nothing but it is the average of these two. So average is what? 56 plus 60, that is 58, and 170 plus 168, that is 169. So
Sir,
this is
sir,
the,
slide is not changing, sir. So
sorry, so I'm really sorry. I'll tell when next time I'll change the, tell the next slide as well. Because if I'm not stopped, then it is, keep on fluctuating. Okay, so it is visible.
Yes, sir.
Okay, so initially I just took, I think I have to. So this slide is over. I think we have already, take the 12 data points, and we just calculate the distance. Distance is 20.8 and 4.5, right? And just we have, incorporate data point 3 into data point 2, and we'll calculate the centroid value. Centroid is nothing but, centroid is what? Centroid is your average value. So 56 plus 60 by 2 is 58. Similarly, 170 plus 168 is 169, right? So just now we have modified. So now we have, two cluster. One is K1, one is K2. K2 belongs to what? K2 belongs to two node ID 2 and 3, and K1 belongs to one node. Once you have the node 3 is in, K2 cluster, so we have to combine these two nodes and find out the centroid somewhere here. So that is the process. So now we have two clusters, K1 and K2. K1 having only one data point and K2 having two data point, 2 and 3, and also a modified centroid, right? Also a modified centroid. So you look at this particular table. Now 2 and 3 is combined and they have the modified centroid value as well. What is the next step? Next step is data point 4 belongs to which cluster? So same, you have to calculate the equivalent distance from 1 to 4. So 72 minus 68 square plus 185 minus 179 square, and this come out to be somewhere around 70.21. When we calculate the equivalent distance from the modified centroid to 4, here 4 to comma to 3, again we calculate the distance. This distance has come out to be somewhere 14.14. Okay, I'm just removing this and I'll just change my slide, whether just give me a moment, please. So my next slide is, I hope, visible to all. Right. So here we have calculated the distance from 1 to 4, that come out to be 7.21. And similarly, we have distance from 2 to 4 or 2, 3, 4, that is 14.14. So the minimum distance is what? 7.21. So that means the data point 4 belongs to which cluster? The cluster number 1. And if it is belongs to one cluster, that means 1 and 4 is combined. That means 1 and 4 is combined. So what is the modified centroid? Again, modified centroid is nothing but it is average value. Average value is what? 72 plus 68 by 2, that come out to be 70. 185 plus 179 by 2, that come out to be 185. So these two data points are now the cluster 1 is combined what? Cluster 1 is combined 1 and 4, whereas cluster 2 combined 2 and 3. So here the modified centroid and here also the modified centroid. Now can you quickly tell me the node ID 5 belongs to which cluster? You just simply look at the table and you can clearly predict them the node ID 5 belongs to Bliss cluster. Okay. So I'll
First
just quickly
cluster. First cluster.
First cluster. Okay. So probably the answer is the first cluster, because if we quickly calculate the distance here, the 72 minus 70, that 4, and here also the 0. So that is the come out to be 2. So the D15 is 2, and whereas if you calculate the 23, 5, that 58 point minus 72, that come out to be 14 is a big number as compared to the 4. So yes, the data point 5 belongs to the cluster this, but the same time when you belong to this, now you have to again modify the centroid. So here centroid value is what? 72 plus 70, that come out to be modified cluster of, now in this case is 71, 182. So now this is the modified cluster, and then this cluster, this belongs to 1, 4, 5, and just keep on repeating this. Now the 6, then 7, then 8, and then this repeat this step, and you can just form a cluster. Okay, so I hope this answer is to be clear. This example is to be clear. So I am changing my slide. It's very difficult. So you can also apply the same formula for the image segmentation. So if you look at it carefully, so this is in the last is my the original image. Last one is my original image. So maybe probably it is having the 256 different clusters. 256 different clusters. If I take only 2 clusters, what happened? So my pixel either belongs to the cluster 1 or cluster 2. You can say the binarization part. If you talk about the binarization part, so it image look like this. When you increase the number of cluster, then the move to k equals to 3 or move k equals to 10, the quality of image the increase. But in the same time, if you have the less number of cluster, if you compare the size as well. So for example, this image may be 10 MB size. So when we use the k equals to 2, this is only the 4% of original image. This is size is only 4% of. So when you increase the number of So this the k-means also use the segmentation, or you can say k-means is also used for compression in image processing, whatever. So this is the one example you can also include in image processing. The how k-means in use the image processing part as well. Now I again you know again I am changing my slide. So now come to the the limitation part of my k-means clustering. If you look at the figure 1 where the green and violet data point is there. So here if I take only one cluster, that is suffices. We fulfill our condition as well. So that is the wrong selection where we had taken the two cluster instead of one. And when we move to the second figure, when we talk about the second figure here, the if I take the value of 2, that is will give you the good result as compared to 1. So that is the some kind of a relation, so limitations to what is the exact value of k in this case, right? So this is the one limitation. So my next slide is maybe visible to all. I hope the visual to all. Now you can think some other, the interesting thing is if you look at the here part, it's almost the similar in this case. So when comparison or the data mining part of this particular scenario and image processing, that maybe give you the wrong result, right? They will give you the wrong result in the comparison. I don't know why this fluctuation has come into the picture. The next slide is the limitation, the third limitations. When we walk on here, the image the segregated very well. If you look at it, the clustering is segregated very well, the orange one and the blue one. But when we apply these kind of the non-convexing shapes, so you it will give you the bad results. So now you can look at it, the here this is the clustering part. So the sum of the orange one is in the blue cluster part, and some of the blue is become the orange cluster class. So it will give you the wrong result. So we have we cannot apply these kind of shapes clustering data to the k-means clustering as well. So I hope this k-means is clear to all. And so Vijay sir, how much time I have? So,
Actually, it was 1:25, so I think that time was over, sir.
time is over. So I'll take some of the question of this KNN and k-means, and also so the same time I'll take the one of the participants wants to interact with the IoT part as well, right?
Correct, sir. So we can take questions.
So thank you all for the patiently listening, and sorry for my the delay due to the changing of my slide due to some network problem. So now I'll take some of 2-3 questions from your side.
Sir, don't you think that time complexity is too high either in the k-means or kn case?
So okay, so yes, definitely this is a good question. As I told you, there is a time complexity and the data point trade-off. So of course, if you go for the simple clustering techniques, so definitely the time complexity is high. But at the same time, it is simple. Right? So yes, true, sir. The time complexity is high in both the cases.
And like you take the example in that for making the clusters, can't we use the genetic kind of things for the optimization and the fasting the task?
you can use the nature inspired thing also.
Any more questions? If you,
Any
okay, sir,
question
I
from
think,
participant side? I'll just look at, okay. So thank you very much, Vijay sir, for giving the opportunity, and thank you all the participants who patiently listening for my lecture. And thank you very much. And if you have any query, you can feel free email me, and on the content I'll definitely share to the Vijay sir. He will share you all. So I'll share you by the evening, sir. Thank
Hello,
you.
sir. Thank you. Thank you.
it was such a wonderful and
Thank you,
interactive
sir.
session.